Our first speaker for this breakout session, which is making the invisible visible, we're going to have with us Garshaw Amity Abraham. He's a senior specialist with the Environmental Defense Fund. His title of his talk is "What's New with OpenET: Updates and Applications for Informed Decision Making in Texas." So, with that, Garshaw, the floor is yours.
Thanks, sir. Appreciate it. Yeah, thanks so much. Hello, everybody. Thanks for the intro, Bobby. Yeah, my name is Garshaw Amity Abraham. I'm a manager at Environmental Defense Fund. I've also been serving as a program specialist for the OpenET Inc. nonprofit since 2021. So today I'm going to cover an brief intro to OpenET, OpenET developments and updates. I gave a talk here in 2022, and there's been a lot of developments in the past couple of years with OpenET. And then I'm going to cover applications of OpenET specific to Texas. So OpenET uses best available science to provide easily accessible satellite-based values of evapotranspiration for improved water management for the 17 states west of the Mississippi River. It's an online water data platform, a consortium, and it's now a nonprofit that's been under development for the past 7 or so years by scientists, practitioners, and water experts at more than a dozen organizations to improve water management in the West. So you can see from the logo soup at the bottom of this slide, it's comprised of government agencies such as USDA, USGS, and NASA, a handful of universities such as Cal State University, Monterey Bay, University of Nebraska at Lincoln, Cornell University, University of Idaho, UC Berkeley, and Universidade Federal do Rio Grande do Sul in Brazil. There are other institutions involved, such as Environmental Defense Fund, that's the organization that I work for, and Desert Research Institute. And there's also heavy involvement from private companies such as Google and Habitat 7. So EDF's role in this consortium historically has been sort of a managerial role of the consortium and nonprofit, outreach and fundraising as well. But now we're less involved in management and more involved in outreach and use case development. And especially in Texas. So we're sort of working, right now we're working specifically in Texas to explore use cases and implement small on-the-ground pilot projects. And generally, we want to learn more about Texas water data systems and where OpenET potentially could fit in. So if you have any ideas or you want to talk further about Texas water data, please, I'd be really happy to talk to you. So just a brief review on what evapotranspiration is. The ET in OpenET stands for evapotranspiration, and it's the process by which water evaporates from the land surface and transpires from plants. It's the second largest component of the water cycle, and it can be thought of as the opposite of precipitation. So it's water that leaves the land surface and goes back to the atmosphere, and as such, it's a measure of water that can't be used in a local system after being applied to the landscape. So as you can see from the slide, some water might recharge an underlying groundwater basin, some might run off and return to a local canal or river, and generally that water can be reused. So water that evaporates or transpires, again, cannot be reused. So OpenET provides satellite field-scale data. Most of this data is from Landsat, but it also incorporates other satellite missions. And each pixel in the satellite image is 30 by 30 meters, or that equates to approximately 1/4 of an acre. So that enables us to calculate ET for most ag fields across the 17 states west of the Mississippi. OpenET provides, really important to note that the ET provided by OpenET is ETA, which is actual ET. So that's ET from all sources. So that includes irrigation, that includes precipitation, root zone storage, and any other ET that you can think of, really. So this slide here is from the OpenET Data Explorer. If you go to etdata.org, you can click through this really easily. That top view is the field view. Like I just mentioned, there's a field geodatabase, and you can sort of click on individual fields and get that ET plot in the field view, and then you can click into raster view, and that's at the bottom, and this is wall-to-wall coverage. So with the raster view, it's not just field boundaries, it's the entire landscape. So you can get different landscape types with the raster view. You can click on a single point, or you can create, or you can draw a custom area with that little box on the right-hand side. You can draw that area and get an ET plot that looks like that. So I encourage you all to go and explore. This is a really great tool to sort of click through and visualize the data, but there are other ways of accessing the data that I'll go into a little bit later. So a big strength of OpenET is the caliber and collaborative nature of the community behind it. Our tech team includes about 30 or more researchers and practitioners from those organizations that I previously mentioned, and all these folks are leading experts in satellite-based estimation of evapotranspiration, cloud computing, software development, and user-driven web design. Also really important to note that the Texas Water Development Board was involved in the very early planning process and stages of OpenET development. And we continue to have conversations with them on how to apply OpenET in Texas. So the reason we have such a big team is to tackle the issue of conflicting and competing numbers for evapotranspiration. So we wanted to bring all of the commonly utilized approaches basically under one umbrella, and also bring sort of the minds behind these approaches together in one place to try to resolve some of the differences and help build trust and confidence in the numbers. So these are the models that are used in OpenET. So behind each one of these models, there's a team of scientists that have been working on these models. Sometimes they've been at it for decades. And all of these models have been used operationally by a state or federal agency. So there's sort of a proof of concept before they were incorporated into the OpenET platform. And then there's a seventh model called the ensemble model. And this was developed by OpenET. And this model averages all of those models and also eliminates the outliers. Generally, the ensemble model is the most accurate model. So if you're just exploring the data, the ensemble model is a good go-to model. So one key piece of trust building in OpenET has been improving its accuracy or assessing its accuracy. Our team completed 2 accuracy assessments, which were the largest intercomparison and accuracy assessments of field scale data to OpenET data to date. So we compared satellite-based ET data against 152 flux tower sites across the US. And these flux tower sites are instrumented with eddy covariance technology. So these eddy covariance towers behind weighing lysimeters are probably the gold standard of ground-based ET measurement. And if they're well maintained, they can provide a highly accurate measurement of ET within their footprint. And the caveat is that they have a very small footprint. And we're very thrilled to share that the 2024 accuracy assessment was featured on the cover page of Nature Water in February of 2024. So just digging into the accuracy numbers a little bit, this slide shows accuracy for cropland specifically. So for water year, there is plus or minus 8.9%. For growing season, have plus or minus 13.2%. At a monthly time step, we have plus or minus 17.3%. And at the daily time step, it's plus or minus 23.6%. So you can see how accuracy changes at different temporal resolutions. So as I mentioned, last time I gave this talk in 2022, we hadn't launched the API yet. These are all the different ways you can access the data now. I just sort of spoke about the Data Explorer. It's a great way to sort of introduce yourself to the data and download smaller bites of the data. Our data is, I think we have a couple decades worth of data in the OpenET Google Earth Engine data catalog. So if you're savvy with Google Earth Engine, you can access the data easily that way. And then the OpenET application programming interface. So this is a great way to request large amounts of data in sort of a more bespoke manner. So, so if you want to specify a certain geography or specific models or specific variables, there are dozens of endpoints to choose from. And also the API is the main way for OpenET to talk to other systems as well. And then finally, the OpenET Farms user interface. This is a pretty brand new interface that's been developed. It's the Farm and Ranch Management Support Tool. And so this interface is really for custom reporting, and I'll show you on the next slide sort of what it looks like. And then you can access the source code for all of these models on the OpenET GitHub open source repositories if you want to look under the hood and kind of delve into them a little bit more deeply. So this is a screen grab from the Farm and Ranch Management Support. This is really a tool for custom data or custom generating custom reports. You can drag and drop GIS files directly into the tool, and you can request automated reports, weekly reports, for example. I'm going to do a slight divergence from this presentation to talk about eddy covariance data for Texas and talk about why I think it's important and worth investing in. So, like I mentioned before, these EC towers, these eddy covariance towers, are sort of the gold standard for measuring ET in Texas, or ET data on the ground. And Texas has a diversity of geography, climate zones, and land cover types. So, so these towers are important for validation and assessment of remote sensing models. They allow us to assess accuracy and increase confidence in the data, especially on a statewide basis. So OpenET has conducted accuracy assessments specific to other states. It would be really great to do a Texas-specific accuracy assessment. In our last one, we were only able to include 2 EC towers from Texas. I understand that there are a handful and maybe even more, and so it would be great to sort of expand that network. Also, identifying systematic bias in these remote sensing models. So these EC towers allow us to identify persistent and/or systematic biases in remotely sensed ET, especially associated with a specific crop type or land cover type. And it sort of increases our understanding of these models, with regards to atmospheric correction, land surface temperature, and vegetative parameters as well. So EC towers will allow us to also understand characteristics of different land cover types and ET signatures associated with those land cover types. Provide insight into how ET data varies with vegetation type, soil moisture, and irrigation and farm and rangeland management practices as well. And I have a slide on that a little bit later. These EC tower systems also collect high temporal resolution data, sometimes on an hourly or half-hour basis. So these can capture ET changes overnight and day, and capture specific events like irrigation events, rainfall, or grass cuttings. So OpenET does have daily data. However, that data is interpolated between Landsat overpasses. And these overpasses occur once every eight days. So this EC tower data helps fill in those gaps between the Landsat overpass scenes. And finally, improving spatial upscaling. So as I mentioned before, these EC tower footprints are relatively small, and satellite coverage obviously is, spans large areas. So by comparing the two, we can sort of refine data scaling and data fusion techniques between those two types of data and gap fill for much larger areas. So the OpenET consortium is filled with, there are scientists that are experts in this field, so they can recommend improvements to our current network and instrumentation, evaluate instrumentation types, guide optimal EC tower siting and network expansion, and provide guidance and supplementary instrumentation as well, like soil moisture probes, weather stations, and provide support for integration of existing data sets and networks like TextMesoNet, and then provide practices for comparing OpenET against these ground-based EC observations. So I'm going to talk about OpenET applications and use cases now. This is a map of a subset of applications of OpenET across the Western US. I'm not going to go through each and every one, but there's a diversity of use cases ranging from groundwater management to irrigation and crop management, to monitoring and reporting, and to even to watershed and surface water management. So I'll delve into some specific examples, especially pertaining to Texas. So generally in the Ogallala, OpenET is involved in locally led efforts to improve groundwater management, development of ET-based irrigation scheduling tools, and incentive-based programs for water conservation tools. Kansas State recently received a $10 million USDA Sustainable Ag Systems Grant Award, and this money supports agronomists, ag extension specialists, and farmers in Kansas, Oklahoma, and Texas in using OpenET to design and evaluate a range of strategies for stabilizing groundwater levels across the Ogallala. Texas Tech is a major collaborator on this project, and the main goals of this project are to understand socioeconomic challenges, identify and evaluate solutions, to use remotely sensed ET to quantify impacts and provide adaptation tools, and also to develop education and outreach on water depletion and adaptation strategies across this region. So this is another example of how OpenET can be, or an example of how OpenET can be integrated into a platform. So just like a bank account, the groundwater accounting platform, which was co-developed by Environmental Defense Fund, the California Water Data Consortium, and ESA. This platform enables water managers, landowners, and water users to track groundwater availability and usage with dashboards and workflows. This platform accepts a wide range of data inputs, including metered data and remote sense satellite ET data. So it's data agnostic. It can accept OpenET data or other forms of ET data. But this platform itself is pretty widely rolled out in California at this point, and it's being introduced in other states as well. So I'm going to talk about GCD use of OpenET. GCDs can use OpenET to understand consumptive use demands and trends in their areas. District level and field scale water accounting, like what the water accounting platform does, or some other data system. Developing groundwater basin budgets, integration into current data systems, like the Texas Water Development Board Data Hub, irrigation scheduling software, or like a data system that we heard about earlier. It can be used in multidisciplinary studies to evaluate best practices and new cropping systems. It can be used alongside other variables like crop yield and soil moisture as well, alongside other tools like soil moisture sensors. And finally, GCDs can use it for outreach and pilot application development. This is a project that we are sort of starting to embark on with Intera. This is understanding pumping data versus ETA on a more local scale. So, so exploring the use of OpenET to inform groundwater management and conservation in Texas. So identifying critical regions and comparing the data with the 2022 Texas State Water Plan, estimate historic and recent ET from irrigated agriculture using the OpenET platform, and comparing this satellite-based ET estimates with pumping data. Not comparing ETA directly with pumping, but first working with the data a little bit, subtracting off precipitation to get to consumptive use of irrigated agriculture. And then finally, engaging local stakeholders to evaluate results and see if OpenET is usable and applicable in this context. And so the ultimate outcome is really to develop recommendations for integration of OpenET into long-term conservation monitoring and decision-making tools. Texas viticulture. So we're also in conversations with a partner we're discussing experimentation with deficit irrigation in grapes in the grape growing regions of Texas. Use of the OpenET API for integration with producer developed tools and dashboards. And just experiment with data-driven irrigation scheduling. So this sort of mirrors how we've worked with larger producers such as E&J Gallo in California. One of our modeling teams, the Alexi team, has developed a tool called GrapeX that is used by some of these wine producers, or specifically E&J Gallo in California. So we would like to have some sort of similar application in Texas as well. Rangeland management. So these are just some ideas on how OpenET could potentially be applied in the context of rangeland management. We don't really have many active applications, but it could potentially be used to sort of identify the ET signal from various rangeland practices, like riparian fencing, rotational grazing, cheatgrass management, and even in stream and river restoration. It could be used to develop basin-wide water budgets in these rangeland watersheds and comparing both wet and dry years to inform these adaptive management practices. And then also integrate ET estimates with higher resolution drone and field data to sort of expedite or cut back on labor-intensive evaluations and explore relationships between ET and biomass and soil quality and other variables. So, so what's next for OpenET? We're working and we've developed a white paper for effective precipitation. It's currently in review, but should be available pretty soon. So this is an automated gridded method for computation of effective precipitation. This variable is very important for calculating the consumptive use of irrigated agriculture. And so this new layer will have lots of applications in that context. Expansion across the continental US. So by the end of 2025, we're hoping to have a full continental US data layer, so from coast to coast over the U.S. And then ET forecasting. Our science team and developers are working on ET forecasting methodology that could potentially predict out ET. I think right now they're talking about over 2 weeks, but not quite sure where they're going to go with that, but should be relatively soon. And with that, happy to take questions. Like I said earlier, really excited to be here, and yeah, if you have any ideas or if you want to talk about Texas water data, really happy to talk about that with you. I also have really cool OpenET stickers if anybody wants one.
Any questions? Seeing none? Y'all can meet him in the hallway over some beers later at the happy hour, right? You'll be there?
Yeah, I'll be there.
All right.
I think everybody's ready for a beer, so.
I think so, but either way, it's great presentation. Enjoyed it. Appreciate you being here.
Yeah, thank you.
And, appreciate you coming.
Yeah, thank you,
All
Bobby.
right, thank you.